All right, folks. So I want to explore exactly how Java constructs multi-dimensional arrays. And in order to understand how it constructs them, it's important to understand array references, which we just talked about. So I want you to remember that, at least in this picture, result is an array reference. It is not an array, okay? So if I want to draw a diagram of what the result array reference looks like, it looks like this. Result is a reference to some kind of array. So what is that array? Well, it's not exactly what you'd think. The array is a set of rows, and there's 4 students here. So there's 4 rows, row 1, row 2, row 3, and row 4. And I can label the index for that 0, 1, 2, and 3. So you can actually say, if you wanted to, you could do a system out print line. That's my short for system out print line. Result sub 0 without any other indices. And that would output the contents of what is in this first row. But what is in that first row is not exactly what you think. It's actually another array reference to the single dimensional array that's in this row. So this is the array that's in row 0. But to get to that array, we have to move through the array reference at position 0 in result. So that is going to get us access to another array, 0, 1, and 2. And that array has the values of 90, 95, and 85. So this array reference at position 1 in result is a reference to another one-dimensional array, 70, 75, and 85. And we have a reference to another one-dimensional array that has the values 90, 100, and 95. And finally, we have the last array that has a reference to 80, 80, and 95. So the way that multi-dimensional arrays work in Java is that you have to think about it like this. Any dimension of the array any array in Java is just a one-dimensional array. Now that one-dimensional array can contain references to other arrays, and that's what allows you to have multiple dimensions. So in this example, where we have a two-dimensional array, let's see if we can use that. In this example, where we have a two-dimensional array, the way the two-dimensional array is constructed is we have a one-dimensional array here, which is a set of rows. But to get to a specific value, you have to move from that one-dimensional array, which is a set of rows, by following the array reference that leaves a particular row and get to the array that array reference is referring to. And that's the set of columns for this particular row. And that set of columns is also a one-dimensional array. So that's pretty much how multi-dimensional arrays are constructed. We could have a three-dimensional array if we wanted to. Let's do that. And so to be thoughtful about this, what would a three-dimensional array look like here? I don't have to write a lot to show you all of three-dimensional arrays, but imagine we have another dimension with a set of grades that go back in time for students from different semesters. So maybe this is the fall of 2020, and maybe this other array here is the spring of 2020, and this array here is grades from the fall of 2019, etc. So I haven't quite shown you the exact syntax for the three-dimensional array, but you can imagine that the three-dimensional array is basically an array of grades that goes back through different years. So the third dimension would be the year that the grade was created. So what would that look like if we had a three-dimensional array? Well, we can do that here. We could say int square brackets, square brackets, square brackets, grades. And this would be, we could sort of think of this as, this is our row, this is our column, and this is the year where, actually I think I would switch it to be like this. So maybe the row would be our, so the row, maybe we'd call this the year, and this would be the grades for that year. So that's a way of thinking about organizing the different dimensions of the grades. And so if I were to draw what grades would look like, and let's say that it's new int, we've got, we'll say we have four rows because we have 4 students. So we have 4 rows. We've got 3 years, and we have 3 grades per year. Okay. So if I were to draw this, what does grades look like? Grades itself must be a reference to a one-dimensional array. So that one-dimensional array is going to be our list of students. We're going to always assume that we have 4 students to keep life simple, and their student IDs. So we're going to have each one of these rows refer to a particular year. So the year itself is going to be, we can sort of think of the year and the grade as a combination, as like a 2-dimensional array, but it's really not a 2-dimensional array. We're going to have years. So let's say we have year 0. I'm going to put the 0 on top, actually. Year 0, year 1, and year 2. And year 0 is going to point to, refer to another array, the final array, which is the list of grades. So maybe that's 90, 95, 98. Year 1 points to another array that is, let's say, 80, 70, 70, and 75. And then, oops, let's see if I can get back to that. And then the final year, which will index by 2, is going to have 3 grades as well, which we'll say is 80, 80, 88, and 98. Okay. So this is the grades for a student in year 0. This is a grade for a student in year 1, and this is a set of grades for the student in year 2. The important thing to remember with this 3-dimensional array is that for each dimension, it's essentially a 1-dimensional array. If it doesn't have data, then the 1-dimensional array is a reference to another array, which may contain references to another array, which then may contain references to another array, which finally will end up referring to some integers or whatever type you have, it's the actual data. So I hope this makes sense to you. This is how you can have in Java arrays of any number of dimensions. We can have 4 dimensions, 5 dimensions, 10 dimensions if we wanted to. I would say for the most part, when you're programming, mostly you're going to encounter arrays in 1 or 2 dimensions. It would be very unusual to encounter arrays with more dimensions than that, but it's possible. And just keep in mind that Java is flexible enough to have as many dimensions as you want, because arrays that aren't data are simply 1-dimensional arrays with references to other arrays, which allows you to construct as many dimensions as you want.